Good morning to all. So today's lecture is about the catalyst, which is porous catalyst. Okay, so porous catalyst performance equations for reactors containing porous catalyst. So that means हमें ऐसे कैटलिस्ट का रिएक्शन इक्वेशन डिराइव करना है जो कैटलिस्ट क्या है, पोरस है, जो बीच में से क्या है, दैट मीन्स पोरस, दैट मीन्स यू नो दैट मीन्स reactors which catalyst which having a porous medium, okay, which is a solid but it consists of hollow. So these types of reactor which is a plug flow reactor. So we see that a plug flow reactor, easily see that. So figure is indicating that consider a thin slice of the solid catalyst plug flow reactor as shown in figure. सबसे पहले क्या करना है, एज अ स्लाइस ऑफ द कैटलिस्ट का कंसिडर करना है, स्मॉल स्लाइस, ओके, एंड इन द बेसिस ऑफ द प्लग फ्लो रिएक्टर. Okay, so plug flow reactor, in that means a reactor which consists of Fa in, okay, so mole fraction is Fa0 into 1 minus Xa in, similar to the at the surface of the catalyst, that is moles A reacted, okay, catalyst ની surface પર જે moles react થતા હોય છે, that is moles A reacted. Then after it is W into R minus R dash is which is equal to the Vs into minus R double dash. So that is exactly Fa out equal to Fa0 into 1 minus Xa out, or volume consistence of delta Vs, volume of solid catalyst, that is delta Vs, and which is the figure is indicating that elementary slice of PFR, elementary slice of plug flow reactor, which is containing solid catalyst particle, solid catalyst particle. So इनलेट एंड आउटलेट हमें पता चल उसके ऊपर से हमें पता चल गया कि एफ इन फ्लूइड इन विच हैविंग अ क्रॉस सेक्शन एरिया A और मटेरियल A. Okay, now the steady state material balance for the reactant A, reactant A के लिए steady state condition allow करना है. So inlet, that means input is equal to the output plus disappearance or accumulation. So input of A is equal to plug flow reactor है, तो input of A is equal to the output of A plus disappearance of A by the reactions. So put the values of the material balance. So it should be in the symbolic terms, it will be Fa0 into 1 minus Xa in, બરાબર, જે અહીંયાથી ઇનલેટ થાય છે, અને એ જ રીતે આઉટલેટ શું થાય છે, Fa out is equal to Fa0 into 1 minus Xa out પ્લસ disappearance કે જ્યાં રિએક્શન ટેક્સ પ્લેસ થાય છે, બરાબર, ઇનલેટ આઉટલેટ પ્લસ એક્યુમ્યુલેશન ટર્મ કે જ્યાં રિએક્શન થાય છે, એ વેલ્યુ શું થશે, મોલ્સ એ રિએક્ટેડ, દેટ ઇઝ WRA dash is equal to Vs minus RA double dash. Okay, so it will be a minus RA dash into delta W, okay, from the reactions. So it will be Fa0 1 minus Xa in equal to Fa0 1 minus Xa out. Okay, so above material balance is differential form is written as Fa0 into dxa equal to minus Ra dash into dw. So from the above material balance, differential form is written as a, simply said that Fa0 को multiplied करना है in the bracket, so that should be remaining term is Fa0 into dxa. Similar to right hand side, it will be a Fa0. Okay, Fa0 is already cancelled. Okay, from the both of side. So remaining term is that xa minus R dash into dw. So we have the values of R dash w is equal to Ra double dash Vs. बराबर, Vs is volumes of solid. બરાબર, તો એના પરથી આપણે લખી શકીએ dwની જગ્યા પર. બરાબર, તો Fa0 dx is equal to minus Ra dash dw is equal to the Ra double dash into dvs, જે શરૂઆતમાં આપણે કન્સિડર કર્યું છે. So for the whole reactor, the above equation must be integrated. This one is only for a slice of the reactor, and we have to calculate for the entire reactor. So it should be must be integrating this equation. So integrating this equation for the entire whole reactor. So we get the integrating from dw divided by Fa0 and dxa upon minus Ra, or it will be considered as a second thing, that is dvs divided by Fa0 and compare 1 to 3. So from the 1 to 3 first and the last is, that is dvs divided by Fa0 is equal to the dxa upon minus Ra double dash. So which is given by this equation, w by Fa0 is equal to integrating from 0 to xa out. So dxa upon minus Ra, or it will be Vs upon Fa0 integrating from 0 to xa out. Okay, now this equation 6.5 is similar to the plug flow performance equation for homogeneous reactions. Okay, this equation is similar to the plug flow reactor. So to bring this analogy closer, it will be that wca0 by Fa0 is it will be the tau dash, and vsca0 by Fa0 it will be tau double dash. So by analogy of the space time, okay, to the space time for the homogeneous system, we may call tau dash as the wait time and tau double dash is the volume time. Okay, space times which is for the homogeneous systems, and it will be tau dash which is wait time, and tau double dash is the volume time. So therefore the integrated plug flow performance equation for the first order catalytic reaction, summation of ea is not equal to 0. So from the analogies to that, the homogeneous reaction is that k dash tau dash is equal to k double dash tau double dash is equal to 1 plus ea into logarithmic of 1 upon 1 minus xa out minus ea xa out. Okay, so homogeneous reaction. Now similar for the mixed flow reactor, this condition is considering for porous catalyst, and for the mixed flow, if we consider the plug flow, this equation should be the equation number 6.58. But if we are considering a mixed flow reactor, so how it would be changed? So mixed flow reactor, it will be consistence of a steady state material balance over the reactor as a whole is similar to the plug flow Fa0 1 minus Xa in is equal to outlet plus accumulations, that is outlet is that Fa0 1 minus Xa out plus Ra dash out into W. તો Fa0 ને આપણે મલ્ટીપ્લાઇડ કરીએ બંને બાજુ બ્રેકેટની અંદર, તો ઇટ શુડ બી Fa0 Xa out minus Xa in બંનેને સાથે રાખીએ છીએ તો is equal to the Ra dash out into W and Ra double dash out into Vs. So it would be the written as a W by Fa0 and the remaining term it should be Xa out minus Xa in by divided by Ra out, और इस तरह से नहीं लिखना है तो हम लिख सकते हैं Vs by Fa0, Vs by Fa0. So it should be Xa out minus Xa in by Ra double dash out. So for the first order catalytic reactions with Ca in is equal to Ca0 in इनलेट को हम कंसिडर करेंगे इनिशियल केस के अंदर Ca0 and it should not be epsilon A is not should be 0. So the performance equation is given by 6.22 6.62. It becomes K dash tau dash and K triple dash T tau triple dash is equal to the Xa out 1 plus summation of Ea Xa out epsilon A out into sigma A out divided by 1 minus Xa out. So this calculation is given here. So the calculation is that W by Fa0 is equal to Xa0 Xa out minus Xa in by Ra dash out. હવે Ca ની જગ્યા પર Ca0 અને Xa in ની જગ્યા પર 0, તો ઉપરનું ઇક્વેશન આ રીતે કંઈ થશે, કારણ કે આપણે કેટેલિટિક ફર્સ્ટ ઓર્ડર કેટલિક રિએક્શન આપણે જોવાની છે. So the remaining term is that W by Fa0 Xa in તો આપણે 0 લઈ લીધું છે તો એ તો 0 થઈ જશે. So remaining term Xa out divided by Ra dash out. Ra dash ની જગ્યા પર શું આવશે? Ra dash ની જગ્યા પર Ra out. So we have the next equation is that Ra dash out is equal to the K dash Ca out is equal to K dash Ca0 1 minus Xa out upon 1 plus summation of epsilon A into Xa out. So the equation written is in the form of W by Fa0. So final equation is that K dash Ca0 W upon Fa0 divided by Fa0 is equal to K dash tau dash equal to Xa out into 1 plus Ea Xa out divided by 1 minus Xa out. So this calculation you do in your words, so you can easily understand that. So basically it is derived from the plug flow reactor, okay, and only this equation, plug flow equation, is asked in a GTU. Okay, so these are the equations of plug flow and mixed flow. Now the other data is given below, that is reactor containing a batch of catalyst and batch of gas. The reactor which is containing a batch of catalyst and batch of gas, so it should be in the form of gas. Okay, so in today's we are discussing the performance equations of PFR. So that is that consists of a reactor which consists of A which is in and moles of A reacted on the surface of the catalyst. So we get the accumulation terms. So simply we derive from the material balance, input is equal to output plus accumulations term. Okay, and similar we derive for the mixed flow reactor, input, inlet and आउटलेट इनलेट जो FA0 है उसे हम कंसिडर करेंगे CA0. So this one is the performance equation 6.663, okay, for the mixed flow reactor.